All right, hi guys. We're going to be taking a look at your inverse graphs with domain and range. So we've already looked at inverses with tables. So we're going to use that idea and now apply it to a graph. So we're going to be finding the domain and range of an original graph and now its inverse. So just to review here for a second, like it says, domain represents all possible x values for a relation or a function, which is specifically measuring from the left side of the graph to the right side of the graph. So we're measuring from left to right. Now, specifically looking at your graphs, looking at left side to right side, that is focusing on your x-axis. Now, if we are looking at the range, that represents all the possible y values of a relation or a function, and this is measured from the bottom of the graph to the top of the graph. So from bottom to the top. And again, if we're looking at graphs, the axis that deals with bottom to top or high to low, that specifically is the y-axis. So let's use these ideas and see if we can look at the domain and range of our original function, and then we'll look at the domain and range of the inverse. So let's get our original function out of the way here. So we have a parabola there on the grid, and it's given us some points. So with that graph there, we're going to go ahead and look at the domain and range in both interval notation and inequality notation. All right, so specifically domain looks at x values. So I want to know left to right, is there any place that this graph stops? Left side of the graph to the right side of the graph. So with parabolas, the easiest place is to start at the vertex. If this was a line, I would recommend start at the y-intercept. So at the vertex, this graph is going to continue to go out to the left, which is our positive, to the left is negative infinity. This same graph, starting from the vertex, will continue to go to the right, positive infinity. So I will use all of these numbers on the x going to the left, all of these numbers on the right. So I have negative infinity to positive infinity. So let's get that down for our domain. Now we also have interval and inequality notation. So the interval notation was the one with the parentheses or the brackets. But since we are looking at the lowest or the smallest number being negative infinity and the biggest number positive infinity, infinities always get parentheses. And again, since we are using every possible number we have there on our x-axis, we have all real numbers. We're using all the numbers on our x-axis. So all real numbers. All right, now let's look at the range, low to high. So any graph we look at, ask yourself, does this graph have a bottom or does this graph have a top? This particular graph has a bottom to it, and that happens to be down here at the vertex, the lowest spot. Now, how high up does this graph go? That's what we're trying to figure out. The lowest spot matches up with the 1 that we have on the y-axis. Our graph never stops going up in either side of it. So then from 1, I use all of those numbers that are greater than 1 because it continues to go up. So again, when I get ready to write my interval and my inequality, that lowest point, that cutoff point is very important. So for my range, again, to start your interval, it's the lowest number, then the highest. So low to high. The lowest number, the smallest y being used was a 1. All the other numbers were bigger than that, so then positive infinity. Now, since that 1 was actually a part of the y-axis and a part of my graph, that's where your bracket comes in. Infinities always get a parenthesis. Now, inequality, here's the one to pay attention to. We are using all the y numbers. So all the y's that I highlighted are greater than 1. Now, since 1 was in that group that I highlighted, it was a part of that parabola, we need that equal to. So all the y's that were being used were greater than or equal to the 1. So now let's get our inverse function up here, and we'll see what happens to the domain and range of that inverse. So let me clean this up, erase what I've got here, and let's get your inverse up here. All right, so we have f inverse of x. Let's get these points. So with each of these coordinates, we have our -4, 5, -3, 2, all of these guys. To find the inverse, I need to reverse those numbers. So let's get those done. So -4, 5, reverse that for 5, -4. So let's go ahead and graph that and see where it ends up. So 5, -1, -2, -4. So there's our first point. Now let's do the second one down. -3, 2, reverse that, 2, -3. There's my next dot, 2, -3. Let's keep going around, -2 and 1, reverse that for 1 and -2. Put that dot on there, and then -1, 2, reverse for 2, -1. So now it's starting to turn again, and our last one, 0, 5, switched over to 5, 0. So there is our inverse of our quadratic function. Whoops, let me try that again and actually hit the dots. There we go. So one thing I noticed, my parabola, which was then originally opening up, is now turned on the side. So it kind of looks like a C shape. So that is very important when we talk about what makes a function. So is this inverse a function or not? Well, we need to test this out. In our last video, we talked about what was called the vertical line test, which said I could draw a vertical line anywhere I want on my graph. And if that line hits the graph more than one time, it could hit 2, it could hit 3, it could hit 4. If it hits it more than 1, it is not a function. So even though that one line that I left up there hits the graph one time, if I move it somewhere else, if I draw it far out here, I hit twice, not a function. So it doesn't matter. If I can draw it anywhere and it hits more than one time, not a function. So this inverse is not a function because it fails the vertical line test, which is what that test was called. Now, for here, just to save on a little bit of time, I'm going to abbreviate this vertical line test. Now, some of your inverse functions will be functions. Some of your inverses will be functions. Not all of them, like we just saw, but some of them will be. So you just have to keep in mind that idea of drawing a vertical line. If it hits more than one time, not a function. So now that we've got our original graph here, I'm going to erase these lines and let's take a look at this specific domain and range. So again, your domain is left side to right side. So this particular graph has a cutoff on the left side of that graph, over there where our vertex is located. So this left point lines up with 1 on the x-axis. All of these other numbers to the right are being used because my graph is going to keep opening to the right, but it stops on the left part of it. So right now we have 1 and everything greater than that. So when we write our domain, our interval notation, 1 is the smallest. It continues to go to the right, so positive infinity. Now, when we do inequality notation, all the x's I highlighted were greater than or equal to the 1. So this looks familiar. Where have I seen this before? I know where. Down here with my original range. It has switched on us. Let's see if that works for the range of the inverse. So let's check that out. So let's go back to this U. I'm going to clean this up a little bit. Now let's check the range. How low does it go? How high does it go? The original U had a lowest place. This time, starting from that same vertex, it's going to continue to go down and it's going to continue to go up. So from that -2 on the y, I use everything under that, which means negative infinity. I use everything going up, which is positive infinity. So my interval notation, negative infinity to positive infinity, and all real numbers. And guess where I've seen that before? From the original domain. So just like an inverse table switches the 2 points, inverse domain and range switches from the original as well. So let's use that idea of switching to answer these few questions that we have. So the graph of a function f of x, which is our original, that is plotted here on the point. What is the domain of the inverse? What is the domain of the inverse? So again, domain of the inverse means I am looking at, follow it back. If I need domain of the inverse, follow it back, range of the original. So that's what I need to find, the original range. So what I want to know, does this graph have a low or a high? Does it have a bottom or does it have a top? In this case, it has a bottom down here at the 4. Since I need range, I'm not going to look at any of these x numbers. So my 4 is being used. This graph continues to point up. So I need all the numbers that are greater than 4. So we're looking at 4 and then positive infinity. Since 4 is a part of this graph, it has to have a bracket with it, while the infinity has the parenthesis. So there it is, letter D. So let's try number 2. So again, domain of the inverse. So that wants the original range. So I don't want to look at any of these x numbers. I'm only focusing on the y's. So let's see what we have here. Low point or a high point? Does it have a bottom or a top? This time the graph has a top. This time our graph has a top, which matches with a +1. Now the rest of my graph is pointing downwards. So everything less than 1 is being used, which is negative infinity. So this time negative infinity is the smallest, the 1 is the biggest. So I need negative infinity to 1, which we're looking at letter B. So let's try our last one, number 3 here. The graph of a function is shown on the grid. We want the range of the inverse. So this time, range of the inverse wants the original domain, because again, they switch. So if I want the domain, I'm not looking at any of these y numbers. All I care about are my x's. So that is from the left to the right. So similar to the graph we just saw, this parabola continues to go to the left. So from my vertex -2 and everything to the left. So that means negative infinity, which is my lowest. And then also from that same vertex point to the right. So all those x-axis numbers to the right, which is positive infinity. So there it is, letter A. So guys, I hope you've enjoyed this video, and please don't hesitate to ask any questions that you might have. Bye guys.